Yeah, so this question we're trying to show the triple angle formula for cos 3 theta. Yeah, so we're trying to show cos 3 theta equals to 4 cos to the power of 3 minus 3 cos theta. So if you want to show any multiple angle formula like sine to the power of n theta, or if you ever want to show any multiple angle formula cos to the power of n theta, you just use cis theta expansion, okay, with binomial expansion. Yeah, so cis to the power of cis n theta also equals to cis theta all to the power of n, which is cos theta plus I sine theta all to the power of n. And then you just use binomial expansion to expand it using the Pascal's triangle 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. Okay. Yeah, so in this case we have cos to the power cos 3 theta. We'll just use cis 3 theta. Okay. So we know cis 3 theta equals to cis theta all to the power of 3. Okay, so it's to the power of 3. We would use this coefficient 1, 3, 3, 1. Okay, so when you expand cis theta to the power of 3, it will just become cos cubed theta plus 3i sine theta cos theta. 3i sine theta cos theta squared minus 3 cos theta sine squared theta plus I sine cubed theta. Okay. And then for cos 3 theta, we're trying to show cos 3 theta. Okay, so we're trying to prove this cos 3 theta here. Yeah. So for this cis 3 theta, it's cos 3 theta plus I sine 3 theta. We just need to make sure, if you want to find sine 3 theta, you equate imaginary with imaginary, which is these two parts. Now we're trying to prove cos 3 theta, so we'll just equate real with real parts. Okay, yeah, so we have cos 3 theta equals to cos cubed theta minus 3 cos theta. Yeah, and we want everything in terms of cos, so we'll change that sine squared into 1 minus cos squared. Okay. And then it will just be cos cubed theta. So it would be 4 cos cubed theta minus 3 cos theta. Yeah, so the first part just done. Yeah, so just by expanding theta, cis theta to the power of 3, we find cos 3 theta equals 4 cos cubed theta minus 3 cos theta. Yeah, so the second one, they just ask you to use a substitution to solve 27x cubed minus 9x equals to 1. Yeah. So all we're trying to do here is just replace x by 3 over 2 cos theta. Okay, so we have 27x to the power of 3 minus 9x equals to 1. You replace every single x by 2 over 3 cos theta. Yeah, so we have 27 2 over 3 cos theta to the power of 3 minus 9 2 over 3 cos theta equals to 1. Yeah, and then when we expand this properly, we get 8 cos cubed theta minus 6 cos theta equals to 1. Okay, so we're trying to use the things we proved before, which is cos 3 theta equals to 4 cos cubed theta minus 3 cos theta. So you can see their coefficient is 4 and 3, our coefficient is 8 and 6. So you just divide everything by 2, so we get 4 cos cubed theta minus 3 cos theta equals to a half. But we also know this entire thing can be replaced by triple angle formula of cos, so that equals to cos 3 theta. Okay. This equals to cos 3 theta. Yeah. So cos 3 theta equals to a half. You could either have 3 theta equals to pi over 3 plus 2k pi, and you could also have 3 theta equals to minus pi over 3 plus 2k pi. Okay, and then we can find the corresponding solutions by letting k equals to 0, 1, and 2. Okay, and then divide theta over. Yeah, so from here we can get two solutions, theta equals to pi over 9 and 7 pi over 9. Yeah, and then from here we can get theta equals to 5 pi over 9. Yeah, so these are the three solutions for that cubic equation. Okay, so because it's a cubic equation, so we should expect there are three solutions. Okay, yeah. Okay, and then the last part. So last part asks you to find cos pi over 9, cos 3 pi over 9, cos 5 pi over 9, and cos 7 pi over 9. Yeah, so just copy them down first. So we're trying to find cos pi over 9, cos 3 pi over 9, cos 5 pi over 9, and cos 7 pi over 9. Yeah, so if you look at it, pi over 9, 7 pi over 9, 5 pi over 9, we all already have it, okay? So cos pi over 9, we have it here. 5 pi over 9, we have it here. 7 pi over 9, we have it here. The only thing we don't really have is cos 3 pi over 9. But if you simplify it, that's just cos pi over 3, right? You can just directly press your calculator and then find it out. It just equals to a half. Okay, so we have a half multiplied by these three things. So those three things are three roots of a cubic equation. Okay. Okay, these are the three roots of a cubic equation. So our cubic equation is cos theta minus 3 over 4 cos theta minus 1 over 8 equals to 0, right? Just for this one, we need to make it monic by dividing every single term by 4, right? Divide every single term by 4. This is monic, and then this is a perfect cubic equation. Okay, and then as a normal cubic equation we've learned before, just quickly do a revision. If we have ax cubed plus bx squared plus cx plus d equals 0, okay, we said the sum of all the roots equals the negation of the quadratic power, so minus b over a, and then the product of all the roots equals to the negation of the constant term, okay, minus d over a. Yeah, so that's the sum of all the roots is minus b over a, the product of all the roots is minus d over a. And so cos pi over 9, 5 pi over 9, 7 pi over 9, those are the three roots of a cubic equation. So the product of those three multiplied together equals to the negation of the constant term. So it would be a half multiplied by the negation of minus 1/8, that's just minus 1/8. Yeah, so half multiplied by 1/8 is 1/16.